What's up everyone, welcome back to my channel. So this is the last video of this year, 2022, or maybe perhaps for some of you when you see it is already in the new year and it will probably become the first video of the year 2023. Anyway, so for the last video we're going to talk about something that is actually pretty simple. And you can actually try to find other videos from Black Pen, Red Pen, and the concept is the sliding method. So as you can see in the title, we actually can use the sliding method to help us factor out a quadratic expression. But have you wondered why the sliding method works? Here is an example. If we have 3x squared plus 7x minus 6, we can first use the sliding method by bringing the 3 and the leading coefficient to the constant term based on how we use the sliding method. So that now we just need to consider how to factor out this expression. And to do that, we just need to think what numbers we need to put such that the sum is equal to 7 and the product is equal to negative 18. So in this case, we will get 9 and minus 2. So we can double check. 9 times negative 2 is negative 18, and 9 minus 2 is giving us 7. So this is good. And now, as we already moved the 3 to the negative 6 at the beginning, we actually need to move it back. But how much do we need to move? Well, let's see. Since we actually bring the 3 to the constant term, we now need to divide the 3 from one of the constant terms and then put it back to the x term. So in this case, we see that we bring the 3 to this side. So now we need to divide the 3 and then put it back to the x term. And this is how the sliding method works. Good. And that's how we get the answer. But why are we allowed to do that? Here is the truth. So if we consider a general expression, ax squared plus bx plus c, and as we want to factor out into two linear factors, namely, we can just call it a1 x plus c1 times a2x plus c2. If this is our final expression, let's try to see what we can do if we multiply them back out. So if we try to FOIL it out, we should actually get the first term, a1, a2 times x squared plus the outer term, which is a1x times c2. So we can just put the a1, c2 together, and then of course there is an x. Then we have the inner term, which is c1 times a2x. So again, we can put the coefficients together or to get a2 plus c1. And of course, we will just combine the like terms or collect the like terms, meaning that if we factor out the x, we will actually get this sum here. And finally, we have the constant term, c1, c2. Good. So what does that do? Well, now if we try to compare with the expression at the beginning, which is ax squared plus bx plus c, we actually need to have the following condition. So in order to have the x squared term be the same for all x values, we need a to be equal to a1 times a2. And similarly, if we want this constant term be the same, we need c to be c1 times c2. And last but not least, of course, we have b is equal to everything inside the parentheses, which is a1 c2 plus a2 c1. And we need to have all these conditions satisfied simultaneously in order to make the expression work for all values of x. So in this case, we can actually see that if we try to use the sliding method, this is what we're going to get. As we use the sliding method, we will turn the original expression on the right hand side be x squared plus bx plus, and now the constant term becomes a times c. And again, that's because in the sliding method, we want to turn our leading coefficient a into 1, and then for that a, we will just bring it to the constant term, so that once we try to factor out this, we will be able to get something like x plus something times x plus another thing. And again, if we try to put it this way, what are the possible combinations we can get? Well, if we look at here, we now need to break a, b, and c in terms of a1, a2, c1, and c2. So it means that now if we try to rewrite the expression, we get x squared plus b, which is in terms of a1, a2, and b1, b2. So we get a1, a2, and c1, c2. So we get a1, c2 plus a2, c1, of course, times x plus the ac term. And again, a is just a1 times a2, and c is just c1 times c2. So we end up with a1, a2, c1, c2. And now if we try to think of the two terms that we need to put to satisfy the condition, it's very clear that we just need to put a1, c2 in one of the factors and a2, c1 on the other factor. So we will be able to get the sum to be equal to b, and the product is equal to ac, or just a1, a2 times c1, c2. And therefore, if we try to bring all the a back to the other term, we'll be able to get the result. So again, the a2 is originally from the leading coefficient a, and a1 is also from the original leading coefficient a. So we need to slice it back and then bring it back so that we will actually get the expression a2 times x plus c2 as our first factor times the second factor, and now we bring the a1 to the x term plus c1. And that's how we actually get the expression that is factored out for the original quadratic expression. And therefore, we can see that why we are allowed to slice it back and forth, because we will always be able to break the leading coefficient a into two smaller factors, and then we will actually see that the smaller factor will actually get multiplied into the constant terms, when we use the sliding method, and we can actually bring it back to the leading term. And that's it. If you think this video is useful, you can just leave a like here. And of course, if you didn't subscribe to my channel and if you want to find out more of my other videos, you can go to subscribe it. I'll have more other videos and different topics. And if you have any thoughts or ideas that you want to talk about in this video, you can leave your comment below. I'll see you guys next year.